Good afternoon, guys. This is Professor David J. De Los Reyes. My topic this afternoon will be still a variable separable, but I will discuss the so-called second order. The previous discussions was first order variable separable. The main topic is still variable separable. The only difference is that the last three was first order, and for this afternoon I will be discussing a second order variable separable differential equation. We are not going out from the topic variable separable. The only difference is that the last time around, the last three is a first order, and for this afternoon it will be a second order variable separable differential equation. Okay, let's proceed. My topic on my channel under the differential differential equation course is actually now DE07, differential equation 07. This is still differential equation. For this afternoon, it will be second order, still variable separable with number 5 over here, meaning this will be my, I think this will be my fourth example on the variable separable, because the last three was first order variable separable. This is the fourth example now, but it falls under second order variable separable. So that's why this is 5. Okay, I will try to give the problem. We are given y double prime. This is read y double prime. It's just like an apostrophe. Y double prime. Y double prime. It is read y double prime. Okay. We are given y double prime equal to 12x cubed. Okay. The initial conditions are y equal to 0 when x equals 0. dy dx is equal to 1 when x is equal to 0. Okay, let's try to bring out the solution. Don't be afraid with the double prime. There is an equivalent of that one. I will read the given differential equation y double prime equal to 12x cubed. Okay. By definition, the derivative with respect to x of dy dx is actually y double prime. Okay. Mathematics just shorten it. Instead of writing the second derivative of y with respect to x, they place it as simply y double prime. Because there are times that there are problems that it is y to the fourth prime to the fifth prime, something like that. But don't be afraid. The first derivative is actually dy dx. So meaning y double prime is actually the derivative with respect to x of dy dx. So we will replace y double prime by this equivalent here. We place it here. So what will come out? The derivative with respect to x of dy dx equal to 12x cubed. Okay? Multiplying all terms by, sorry for that one, multiply all terms by dx. Right hand side, or left hand side rather, dx will cancel. So what will come out on the left hand side will just be simply the differential of dy dx equal to 12x cubed dx. After the multiplication of dx for all the terms, actually we already have separated the variables. That's why the topic variable separable. Okay? Integrating both sides. Integrate to bring out the solution. The integral of the differential of dy dx equal to the integral of 12x cubed dx. We are now integrating. Okay? For the left hand side, as I have told you in integral calculus, when the integral sign goes near this differential sign, they will try to cancel out each other, okay? So what will come out on the left hand side will be dy dx, okay, equal to, the right hand side is integrable, a constant times the power function, right? So we bring out that 12 over here, and the integral of x cubed dx, it falls under the power formula. Easy money, guys. X to the 4 over 4. 3 plus 1 is 4 over 4 plus k1. dy dx now will be 3x to the 4 plus k1. Actually, this is now a general solution, but this is not yet our final solution, because if you try to notice the left hand side is still dy dx. And the problem is actually asking for y as a function of x. The given equation was differentiated 2 times, okay? That's why it falls under second order. That was the definition of order. The maximum number of times that the given equation was differentiated. That's why our topic for this afternoon is second order. So meaning after the first integration, what comes out is still a differential equation. It is not yet y as a function of x. Okay? Let's try to compute for the value of k1. From the given initial condition, dy dx equal to 1 when x is equal to 0. It is this. Right? So substituting the value dy dx equal to 1 and x equal to 0 back here, 1 will be equal to 3, 0 to the 4 plus k1. 0 to the 4 is actually 0. 3 times 0 will be 0. So this is actually 0. Therefore, 1 equal to 0 plus k1. And since this is 0, we could remove this 1. Therefore, k1 will be equal to 1. k1 will be equal to 1. So the resulting particular solution for the differential equation over here, we'll go back here, we place the value, the computed value of k1. k1 now, dy dx now, I'm following this, equal to 3x to the 4 plus 1. This is still a particular solution, but unluckily, this is still a differential equation. Right? So to bring out y as a function of x, okay, take the differential again of both sides. So what do we do? In here, try to separate again the variables, right? We will multiply this one by the x again. Right? It's always the main topic, variables, separables. Separate again the variables to proceed with the integration. Therefore, dy over dx times dx cancels. Right? Left hand side, what will remain will be dy. Right hand side, it will be 3x to the 4 plus 1 close quantity dx. We separate the variables already. Right? Integrating both sides. The integral of the differential of y equal to the integral of the quantity 3x to the 4 plus 1 close quantity dx. As I have told you in integral calculus, when this integral goes near this differential trine, they will try to cancel out each other. So left hand side, what will remain will just be simply y. Right? Equal to. On the right hand side, it falls under the integral of a sum, right? So just take the sum of the integrals. Just inspect the sum. The first one is a constant times a function. The second one is actually a pure constant times differential x actually. So the first one will be 3. then this will become x to the 5 over 5, which is a power formula. 4 plus 1 is actually 5 over 5, plus the integral of 1 times dx. The integral of dx will just be simply x plus k2. Okay, there should be a constant of integration. To solve for y now, we bring out the first initial condition that y is equal to 0 when x is equal to 0, right? So we'll go back here, we place y equal to 0 and x equal to 0. Therefore 0 equal to 3 over 5, 0 to the 5th power plus 0 plus k2. 0 to the 5th power is actually 0. 3 over 5 times 0 will be 0. So this will be 0. Plus 0 plus k2. This is 0, this is 0, we could remove it. Okay, therefore k2 now will be equal to 0. So actually k2 will be 0. So to bring up now the particular solution, go back here. Substitute the computed value of k2. Therefore y now equal to 3 over 5 x to the 5. I'm following this. Plus x. This is actually plus 0. But plus 0, it should be 0. So the particular solution for the problem will be y equal to 3 over 5 x to the 5 plus x. Particular solution. That's our answer. We are now given y as a function of x. Okay? So it is the particular solution. You see guys, under second order, we integrate 2 times because the given function, or meaning the particular solution, was differentiated 2 times to bring out this one. Okay? To bring out this one. Meaning to say, you try to differentiate this one 2 times to bring out the original problem. That's why it is y double prime. It is second order. Order is actually the number of times that a given function is differentiated. And for this problem, supposed to be, the particular solution was differentiated 2 times to bring out the original problem. Oh, how about the graph of this one? If you could plot your graph, no problem. It's easy. Assume a value of x. If the value of x, sorry for that one, if the value of x is 0, this will become 0, this is 0. So when x is 0, y is 0. Right? This one. Try to increase the value of x. If x is 1, the value of y will be greater than 1, maybe here. Right? At x equal to 1. When x is equal to 2, as you notice, this is to the 5th power. Okay, so it will be a big value. Plus is still 2. So this might be the graph. Point. When x is equal to 3, 3 to the 5, that will be a big value. So actually, as you increase the value of x, y increases also. So actually, this is the graph of the equation. And the equation of this one is actually 3 over 5 x to the 5 plus x. It looks like similar to the exponential equation. Because as you increase the value of x, okay, this is raised to the 5th power, it's a big value. So as x moves from 0 going to the right, it's going up. So we could say that it looks like the fat of a missile maybe. Oh, that's it guys. An example of a second order variable separable problem. So don't be afraid with y double prime. Y double prime, the meaning of that is that the given function is actually differentiated twice. That's why it is second order. Good afternoon, Los Angeles.